So wait a minute. Mm, mm, mm. All right. So once again, good morning from Thailand. Actually, I think that is Thailand might be a little earlier from your country. I mean, might be 1 hour.
Yes,
Mr.
that's right.
Hani just informed me yesterday. Yeah, because if I look at the table, I might be late for this presentation. Thank you, Mr. Hani, for remind me about the time.
I just remember
Okay.
actually.
uh, all right. So uh, the topic that I going to present today is the sustainable material and construction toward climate change adaptation from your team. So I think you already introduced me already for detail, but I just might be a little bit. My background, you can see that my background is I working in the Suratnadi University of Technology in Thailand, but I'm from Cambodia, of course. And but I live here for 10 years already. And my research field is mostly the material. But if for construction material, it's the underground construction, the foundation, or we call it the geological engineering construction material, right? And mostly it's the geopolymer stabilization. And the geopolymer stabilization, it can be work in this field because we try to reduce the what is the cement material, right? So the geopolymer material we try to replace the cement in order to reduce the. I also work actually as the consultant with the Center of Excellence in Innovation for Sustainable Infrastructure Development that we work with the group of for today. The key term I mostly I might be say the three keyword or key term: sustainable material. All right, and that we're going to talking for more detail about today. And the sustainable construction, so a material and construction might be go together. But the more thing that I might be concerned the most is introduce you about the climate change. We might be know and hear about this term very often about climate change, but what it's going to be a serious problem. I might be just take some example or some definition of the climate change. So we can go to the climate change. Like, what is climate change? Everybody might be heard about this term and hear that is very often because I mean this is for the global concern for about the climate change. It can be have a lot of definition if you can just Google it and have a lot of term that is defined. But I prefer to use that a short but simple, which is the significant change in global temperature and weather pattern over time, especially in Thailand. I don't know, might be in your country, but in Thailand we have before we have like might be cold weather and hot weather, but right now in Thailand we have only 3 seasons. It's like hot, hotter, and very hot. All right, so the temperature increase every year. Mr. Honey, he stay here. He might be know the situation is very hot. All right, and the weather change over time. It can be like flooding. It can be storm or whatever, and that is the most influence or most problem. But we have to deal every year. All right. So if we're talking about the climate change, it can be divided into 5 items, or 5 topics. What the cause of climate change? It's a global warming. All right, the global warming is I mean, the long term, the increase in the temperature, and this for our globe. All right, so the temperature still keep increasing, and approximately like 1 to 2 or 1 to 3 degrees Celsius for annually. All right, so that is the most challenging for the globe, right? And the greenhouse gas emission is the one of the concern for the global as well. When I think most of us might know about the carbon dioxide, which is from the industrial, and it's also from the construction as well. If I will be showing you in the next slides, which is what is the serious problem from the especially civil engineering construction. All right, and the way the pattern chain, right? Before it's like it can be said that every year, for example, from this month and to that month, for example, from January to April, it's like it's hot season. There's no raining, but sometimes it's changed. Even in hot weather, it have a huge rain, or it can have a storm. But in the rainy season, sometimes the rain is not come, so it becomes drought and very hard for the farmer. Right, so this is the pattern that is influenced from the climate change. All right, and another one is like sea level rise, which might not affect from our country a lot, but it in Europe, for the country who have the like the polar ice, when it melting, it can increase the sea level, but in this can be cause the flood. And the last concern is about the ecosystem or a biodiversity. All right, you can see that a lot of species have gone, and animal or this one is related to the human as well. Okay, and if the farmer cannot as well. All right, so this is all I can say about the climate change, which is influenced from human activity. Actually, it can be said that it's naturally it can be happen, but I think human is the key driver to make it very go very fast. All right. Okay, so let's take example of the case study from the climate change, that is the 5 items that I just mentioned above. We have a lot. I think we have a lot, but I just take some of the obvious example, the influence from the climate change. All right, in Australia, we have a very high temperature, like a heat wave, which is happened in last year, I guess, as I remember, because my research collaboration is from Swinburne University in Australia, and we work together. We still work together, so I know that during the heat wave in Australia, the temperature increased very high. So it's almost like 40 degrees Celsius, which can have a heat stroke for some people. All right, so that is very serious problem in Australia. When it's hot, it's quite hot. All right. And okay, so come back to Thailand. If you follow the news, Thailand is always faced with the flooding problem. Right, flooding problem is not even in the city, but it might be some of area from the province, because if you look at the Thailand geography, Thailand was covered by the network of the water flow. We have the river, we have a lot faster from the natural, right? So it have a flood, which is very hard for the city, especially Bangkok. People very always challenged with the flooding. All right, and when it's flood in the province, it will be influenced from it will be effects to the farmer, right? Which can be a big or very serious problem for farmer. All right. And similar situation, it's also not only in Thailand, but it also happened in Philippines, right? In Philippines, and my friend who just graduated from our Suratnari University, I mean, I have some time to talk to them. They are in Philippines. The problem is quite similar because of the geometry of the country and all right, so I think in most of the country in Asian country, it also influence or experience with the flooding, but it's also happening in what in Europe country, especially this one it in US, in the United States. They have a huge storm that we known as the hurricane, right? A hurricane that is the big problem for the American people. Okay. And so when we come back to the melting, this is the north of the pole in Europe. We have the mean sea level, which is melting by the increase of the temperature. All right, so I just go straight very fast about the climate change. So when it melting and when it come back to, I'm in China, the flood, you can see the climate change is mostly flood every works, every industrial. Once the temperature causing and beyond the, except the, besides the flooding, but in some country experience with the drought and the temperature is very high. It's quite similar to Australia and Japan. Some heat wave or effect, as we know that the Japanese people, they experience mostly with the cold weather, but when the temperature increase very significantly, it can give the heat stroke to the people. So the government take it seriously on the climate change. And even some in European country, like in Brazil, the drought that is, we know that they produce a lot of like in agriculture products, right? Especially like the coffee beans, but due to the climate change, it can be damage their farmer as well. All right, so this is in just short briefly about the effects of the climate change, right? But it is in general. All right, so this in general. So okay, come back to the last slide. That is also affects a lot in Thailand. This is the we call it PM 2.5, which is generated by the agriculture products and also with the industrial and with the like cosmetic, like how to say the vehicle, the transportation, especially if you have chance to come to visit Thailand in Bangkok, especially a lot of traffic jam and because of over number of vehicle transportation is the problem. So it can pollute the air. So that all right. So after we know that the climate change are now, it's seriously threaten our nation, our global. So these topics, this webinar, we're talking about the climate change and adaptation. So with the adaptation, I go with the mitigation. All right. So these two terms, it should be go together. The mitigation, it's referred to the effort, the human effort, try to reduce the greenhouse gas emission, right? Which is, we cannot, we cannot eliminate it 100%, but we try to reduce it, right, to a limitation for the future climate change, right? And that is why we need to adapt. So adaptation refers to making adjustment we need to adjust. We need to have some reflection of the our activity and the natural system in order to protect the environment, right? Which is mean that trying to not to enforce or foster our climate change, right? So if you look at the construction and climate change, so you can Google it and search from this available resource. We can see that the global greenhouse gas emission by sector, those are main factor. Transportation, of course, actually number one. If you look at this one, number one is industrial. From the globe, it produces a lot of CO2, greenhouse gas emission, and followed by the transportation because of the vehicle. Right, the vehicle produced by the smoke fuel vehicle. But actually, if you combine the construction, the building operation, and the building and construction material, it's also a main measure, the big, like the three king of producing the emission, the greenhouse gas emission. So construction need to be concerned the most as well. All right, that is the topic that we're going to talk today. All right, for number two is the construction. It's most of the construction, especially for high-rise building or for urban planning development, for the house development. You can see that the construction consume a lot of natural material, right? A natural material for construction, even for the high-rise building, for the road infrastructure, for a pavement, for a highway. We consume a lot of natural raw material, all right? And number three is along with the new development of the infrastructure, for those building, or I mean, let's say the infrastructure which is cover all, it will be demolished. Demolish is mean that we have to demolish it first before we construct a new building, because the building, it might be has some age. It's like people, right? When it reach it designing life, we have to demolish it and then rebuild a new one. So those, you can see that the process of demolishing, it will be have activity to generate the greenhouse gas emission, and the waste, it become the problem. You have to deal with this waste in not to give this, or is not to deposit this on the landfill. All right. And actually my major is now, or my research field, I'm working a lot with this waste material in order to convert it, recycle it into be construction material again. And at the same time, energy use, we need a lot of I would say heating, cooling, and electricity. In Thailand, for example, when it is during the hot weather, we need a lot of electricity to cool down the building. So that is the main problem as well for Thailand. And electricity now, the price of the electricity, it increased because why? We have a lot of concern, which is we also have the mining that can produce the electricity as well, but mostly the available resource and the main resource is from gas. But during the world or the global situation like Russia and Ukraine, now the problem is the limitation of the gas. So that is the price of the electricity. It's increased significantly. Right? That is the problem for Thailand. And the one is the urban heat island effects. Again, if you experience in Thailand, if you come visit in Thailand, I mean, in the urban area, especially in the city, it's like Bangkok. I think most of the city in this globe, I mean, might be in your country as well. In the city, the temperature is always higher than the province because of the urban heat island effects, which means that it comes from the those three things, which is industrial, transportation, and the construction, right? So make it the temperature and the air pollution affect mostly in the city. So the thing is, how could we have the city people by concerning about the sustainable material and the construction? Okay. So what is the importance of sustainable construction then? For the construction, especially in my works, is we need to make sure that not only the construction material, but it's the construction technique as well. We should adapt and we should have change in order to reduce the greenhouse gas emission or CO2 emission, and try to eliminate the natural material, the raw material, and then using the recycle or a recycled material. It can be one of the thing that we can concern in the sustainable construction. All right, so what about the sustainable? It came to the second key term is the sustainable construction material. So what is the construction or sustainable material? We have a lot of terms, but I might be the most experienced. I work in my field a lot. Is the first term is renewable. All right, the renewable, which means that they are made from resources that are replenished naturally and rapidly. That is unnatural, right? I remember one time I like TikToks. I watched that, and I forget that TV program. They said they're talking about a lot about the sustainable material, and one people say that they try to cut down the forest because it's natural material, and they say that this is the environmentally friendly solution if you compare making the concrete. And that guys, the operator argue with him and like put the blame on him, because say that when you're cutting the forest, it is the big problem with it. You are trying to vanish the environment, and this is one of the key driver to the climate change. But actually, if when listen to his explanation, is mean that the tree it's renewable, but it just takes some time. It might be take longer in order to renew, to grow. All right, but if you compare to the concrete, you have to demolish, or you have to, how to say, destroy the mountain, big mountain, in order to get that raw material, the aggregate, in order to produce the cement, in order to produce the concrete, which is never renewable. When you destroy the mountain, it will be vanished. It's never come back. All right, so this is one of the way which we consider about the renewable material. All right, so we have example after this. And for the recycle or reuse, I work a lot on this one. So recycle, we can say that it reduce, reuse, or recycle. These three terms should go together, and those are from the construction of the construction material itself, like the building. It's like the highway or pavement or other infrastructure. When you demolish it, it become the waste material. But some waste material, it can be used as recycle, but we need the treatment. Of course, we cannot use it 100% of those, because of the quality of those material might be not meet the criteria for making the construction again. All right, and another one is might be the non-toxic. The non-toxic material is for architecture. Maybe you might be concerned a lot about these material when you produce some material and then try to applying to the building or the house. It can be concerned with the environmental problem as well, especially the environment, the air pollution, or using the painting, for example. So we try to find the other alternative material, which is like bioorganics material. And another sustainable material that we concern might be energy efficient. Some building, it need some material in order to reduce the energy. For example, you might be designing the building with more, I would say, the lights, the light in order to reduce the effects of the electricity. All right. Well, when we talking about the construction material, is the insulation material, which can reduce the heat from the outside, so it can be cooling down the building. All right, and this material might be with the expert of Mr. Honey. He worked a lot about the energy efficiency. I think he might be introduce you about this for more detail. All right, and with the other thing is a local resource. I mean, the available resource which can be found at the field of the construction. I can take one of the example. For example, when we build the highway, the process is we need to build the strong foundation. Otherwise, you can see the road of the pavement, it will be fail very early age. Okay, so those materials have to meet the requirement. But of course, this is in general. In mostly the available, I mean, at the size, the material might be not pass the requirement because of the quality. So in order to do that, we can have techniques. We can have the construction techniques, or we have the improvement techniques. Like we can use the chemical substance, we can use the geopolymer substance like I did, in order to improve the local material. So we don't have to find the other material from far away from our construction sites. So if we do like this, we can reduce the transportation. All right, because of the transportation or the mobility of the material, it will be give you the highest emission as well. All right, and another one is make the material last longer, and trying to enhance the durable material. So when you have the dual material, you can use long lasting. You don't have to change it very often. Like for example, the building you are designed for 100 years, so you have a very durable material. Otherwise, it's just like 20 to 30 years. You have to destroy it. You have to demolish it and rebuild it again. All right. So this is the way of the durability or long lasting. Okay, so come back to the sustainable construction. This is all the techniques that we might be probably consider, because we know that if construction consume a lot of natural resource, what we're going to do is try to reduce the environmental impacts and creating the healthy space, which means that some building we use the technology and traditional way should be go together. I think this one, most of the architecture, you are mostly in this expert in this field. For example, trying to design the building, what you need the light from the natural, from the sun, in order to lighting the building. When you have enough light, we don't need the electricity, or we can reduce the electricity in order to produce the lights. All right, so this is mostly related to the sustainable construction. If I have some time, I will explain about the construction techniques. What is the engineering consider when we reduce the environment or climate change? All right, so I think I may need some time. I will go fast now because time might be running out. Okay, so for the construction material, a renewable material, this one of the projects which I get involved with the university from Austria, and a university from Austria, like the government, they cooperate with the Thailand government and also our SUT university, the relationship between our university. Even in Austria, the European people, they don't have the some kinds of situation like this. I mean, the raw material like this. Let's say the bamboo, right? bamboo is the renewable material. So this is one case of the sustainable material. In European country, when I talk to them, they don't have this kind of material, but they can adopt and use this material as a construction. For this is like building a guest house in Chiang Rai, one of the Chiang Rai, which is the to Laos, and I get involved in this one. You can see that they have the bamboo as the structural member for the building, and they use the adobe or the brick, or we can the blocks, and generate from the available material. This is from the local. They use clay. They use the like from the agriculture waste. Look at this, and with just the human activity without the equipment. So when we use the equipment, it can reduce the electricity, and we can reduce the greenhouse gas emissions. So this is, we call it the sustainable diversity projects. All right. And one more thing, this is, continuous from that project. So I'm going to produce, I'm going to develop the other material, which is trying to reduce the environmental impact in both in Thailand as well. If you remember, I mentioned earlier about the PM 2.5, the air pollution in Thailand is very serious, and it's usually from the rice field farmer when they burning the straw, all right, the rice straw. So what happened if we trying to recycle, not recycle, to reuse this in the construction of material? We have a lot of research working on this rice straw. They use as the plate and the disc, and it successfully can develop those material and export a lot to India. All right. So what if we trying to use as adobe and using these blocks? But we have a lot of pattern to use this. All right. You can see we can have the crushed rice straw, or we can chop it into the small particle, or we can crush it into the powder. And after that, we're trying to use making the brick not using cement. Why? Because cement is one of the most serious problem generate the greenhouse gas emission. So we try to use another alternative additive, and we found that this material, it can be used as the sustainable brick or wall, which is can use as the insulate and to protect the heat as well. All right. Okay, so this is one of the example, which is they use the straw bowl as the housing in India. So we lesson learn from this projects. We're going to adapt this and apply it in our construction, in our projects in the future. I think it might be hopefully we're going to start this project soon. Okay. So in another way, yeah, hemp. All right, hemp fiber is the honey. We work with this a lot because with cyclone. But for me, okay, I also work in this field as well, but we might be work with different application, for example, because of the hemp, and it might be not legally in some country. I think from your country, in Indonesia might be not legally yet, because this hemp is some kind of the drugs plants, right? And in Thailand, it's just like we just announce it publicly legally, but not in general, but it still have some restrictions. But what I'm going to explain is about the this is renewable as well. The agriculture, which can be adopted to use as the construction material. The of the hemp plants, it also can, what do we call, it can be consume a lot of CO2 as well. And this, it can be divided into main like stalk. From this stalk, it can be have the fiber, and it can be have a herb. And if you look at on the right hand side, sorry, we have a lot of kinds of material. It can be have a fiber, it can have a stalk, and it can be have a herb. All right. So we can use as the block as well, block for the construction. But for me, I use the fiber to include in the concrete and improve the flexural strength for a pavement material. Right. All right. So when we come to the infrastructure, pavement infrastructure, that is what I'm doing a lot. If you look at the pavement, the construction of pavement, we have two kinds of road. One is concrete pavement, and another one is asphalt pavement. So the underground is quite similar for the foundation, but the difference between these two kinds of road is a concrete, which means that the surface only. When the surface is made of concrete, we call it a rigid pavement or concrete pavement. But when the surface making by the asphalt or bitumen, right, we call it the asphalt pavement. And all of this layer, we have the different layer. It's not only for example, it's not only concrete. When we build a road, it's not only pure concrete for the whole thing, but we have the foundation. We call it sub-base, base, and surface. So base and sub-base, we consume a lot of natural material, the crushed rock, a limestone, like a limestone or basalt or granite. All of others from the natural, or sand from the river, and this is from the mountain. We have to destroy the mountain. Okay, so that is what we consider the most, is trying to replace this by alternative material in order to use in the pavement. Imagine that building the highway or the road networks, it's very huge, very long. So if we can reuse it or recycling the waste into this infrastructure, it will be both benefit to the reducing the environmental effects and also the cost of the construction. All right. So what I have done so far is using those are from the industrial or from the construction as well. For example, wrap, I call it wrap. It actually from, we call it recycled asphalt pavement from the existing asphalt itself. When it reached their design life, for example, after 10 years or 50 years, they will be destroyed and it will become the waste. So in Thailand, we have a lot of this, and we just put away along the road, which is never use it. So we try to reduce this by include this into sub-base, base, and surface. Right. And also RCA, we call it recycled concrete aggregate, but from the building. Right. And the slags from the steel industrial, waste glass, and plastics. So PET now is the most concern for the globe as well, because the plastic is very it takes so long to decompose, right? So we try to input more PET or plastic waste as well. The crushed bricks and the fly ash. The fly ash, I think we have the same situation. Thailand, when we mining for generate the electricity, right? We produce a lot of fly ash from mining. And I have opportunity to talk to university in Indonesia as well. I forget the name of that university. And I think we would like to develop this in auto construction of material as well, because this, it can be the below, it can be used as the geopolymer material that I mentioned a moment ago. And also now I work with my PhD student who just graduated, and he's a lecturer in the university in Vietnam. Fly ash, it from the mining. We have a lot of mining in Vietnam as well, so we develop together to use as the blocks, a block from the west as well. Okay, so all of those are recycled material, and for sure it cannot be compared to the high quality or natural quality of the natural products, right? We need to stabilize, we need to improve the material, we need to improve it by using the chemical substance, right? So the chemical substance that can be used is cement, a Portland cement. A lot of people know that when we make a concrete cement, it can be used to improve in processing the cement from the manufacturer need the time about 1,400, 1,500 resources, and you can intensive and also produce 1 kilogram, and it can gram of material like alkaline activate material or geopolymer or base cement, right? So I work with this, all of this. Okay, so let's see. For example, one of the example we just work on this. This is the recycle aggregate, which is from the building. So when we have to crush this and become a particle used for a concrete material, and using the cement, even the cement, it can be, we know that the improvement of the quality is the cement, but when we have a lot of too much cement, your material become brittle. I mean, brittle, it will be easy to break. Like, for example, if imagine you have a glass or bottle, and then you drop it, it's easy to break because of the brittle material. The cement will be generate behavior like this. So what we're going to do is we're trying to improve this material by using the natural polymer, is the natural rubber latex from the lumber plants. So when we include this polymer into the concrete, it can be improved the flexibility, or I mean the flexural strength will be increased. So when we improve the ductility of the material, it become, I mean, the durability of the material, it can be last longer as well. So this is one of the concept which is related to the sustainable material. All right. And so we did the complete works, all right, for the quality of the material. Of course, the mechanical engineering property, we need to make sure that those, when we reuse it, our method can be meet the engineering property. All right, and another one's the pavement. Take one of the example. It will be exposed to the environmental change. Sometimes it rains, sometimes it dries, sometimes it flooding, sometimes it drought. All right. So this is all of the effects which it can be reduce the durability of the material. And when we use the recycled material, some it from the industrial, it will be have some contaminate material, contaminate like mentality material, right? Heavy mental, sorry, a heavy mental, it can be leached out from your material, and it can be pollute the pollution, like the water cost, the water resource. So what we're going to do, we need to test it to make sure that those material will not give to the environmental burden. So we do both the durability, again, the wetting and drying process, and also the leaching test, in order to test that the liquid that is leaching from our material will not affect the environment. All right, so this is the complete thing that I did for all of the material in our research team. Okay, so it successfully proved that those material can meet engineering property, also environmental concern. All right. Okay. That well, this is the asphalt. They check that work with the Department of in Thailand for the asphalt pavement. For the asphalt pavement, we use what is the component of asphalt pavement? Asphalt pavement is composed of aggregate, all right? The aggregate and the bitumen. A bitumen is from the petroleum, it's chemical from petroleum. So when we meet together and it become like strong one, you melt it down. I mean, the bitumen material, it need to be melted. The temperature at about 150 to 160 degree, also high temperature, right? So the behavior of the mechanical, I need to explain a little bit about the mechanical. The mechanical property of the pavement or asphalt pavement, it's a contact between the aggregate. You can look at this. So once is the pressure of the vehicle come, it's subject to both compressive strength and flexural strength. All right. So when you're trying to imagine if you have the slab of your house, right? It's similar to the slab of the pavement, but it's just longer and it's not, but it stay on the ground. So when the vehicle come, your pavement or your slab will be here, right? Will be bending, subject to the bending. So the flexural strength will be the most concern or the major problem, right? So in order to improve this pavement, we need to improve the flexural, I mean the bending of the bending behavior, right? So what we're going to do is include the fiber. All right, what will be fiber works? Here we go. So this is actually, we use the commercial product of fiber products is the we call aramid and the polyolefin, a combination of these two together, because it's just like we put just a small amount, it's like about 0.03 to 0.005% of the construction. It can significantly improve a lot because of, I mean, the fiber is working as the bridge. And we can that do with the Department of Highway, we do the trial construction testing. You can see we have different kinds of material. This is the original AC 6070 asphalt without any improvement. And another one, we use the asphalt pavement. We use the fiber, this one in the asphalt pavement. And this one is the polymer. I mean, the PMA, it's the commercial product, but it's very expensive. It can improve the strength for sure, but the price is very expensive. So what we're going to do, we have made the experiment in the laboratory and also in the field construction, and then we're recording the data. We can see that we can observe that for the asphalt pavement, the original one without any improvement, we use as the reference. All right, and so when we compare with the fiber inclusion in our material, the construction is trying to drop. Why? Because of the material can be improved. I mean, the mechanical property can be improved, and the thickness of the layer have reduced. All right. So once the layer have, it's reduced, it's mean that the human resource also reduce, and the construction process also reduce, which can save a lot of money and also can benefit to the environmental burden as well. All right, so I think this is one of the example which from our research team. I think we have a lot of more than case study, but because of due to the time, which is I cannot cover everything in our slides. And we also conduct the experiment in our laboratory and also our university campus using the recycled aggregate like RCA or RAP, recycled asphalt pavement, recycled concrete aggregate with the natural rubber latex, that is the natural polymer in our SUT. All right, we construct for almost a years, and now the road is still under the process and it's still going well. So we assure that the sustainability of this recycled material, it can be significantly improved to our university. And our university now, we just passed the 30-year anniversary, and the score or the mark for the climate change, I mean for the SDG, it can increase because of we adopt a lot of sustainable material and construction. Okay, so all right, so for the challenging of the sustainable material, now it can, you can see that a lot of material can be your work, but it still have some limitation, or it very challenging a lot is, I mean, how to include those material, how to increase the material, I mean the amount of the material, because now we can just limit it. It's about like less than 50%. For 100%, I mean, this is the challenging for using the recycled material. And lack of awareness, because a lot of people might be, they know of the climate change, but they don't know about how do we recycle or recycling or reduce this material in the environment. So this is the challenging of the environment. All right. So the goal of the action, which is one of the activity that we're doing now, and thank for your university that organized this activity. So to improve the sustainable construction, when you doing the research or doing your study, you know, you might be keep in mind, bear this in mind, that you're choosing the sustainable material when you build your house or your renovate your house, your building, or other business which is related to the construction. And a company or support those I would say entrepreneur who try to use the recycled material in the construction. All right, so this is some our future works. All right, so for conclusion, all right, now we come to the end, and I think I have more project, but maybe if we have some time later, we can discuss more. And that one is for the construction process. For example, the foundation, we use the drilling process using the screwing pipe rather than using the ball pipes or a driven pipes, and also using the screw pipes, instead of the conventional pipes, but might be a lot and too much for that case study. So I just come to the conclusion that the construction industry have a significant impact on the climate change, like 1/3 of the activity that it can generate the climate change, or key driver to the climate change. So if we can use the sustainable material, which is renewable, recyclable, into the construction projects, of course, it can be significantly reduce the environmental impacts. All right, and remember that using the recycled material, it need cost, it need money, it need budget, more budget, because why? We need the way to process it, we need the way to improve it, we need more technology, we need more techniques to improve it. But it was to invest because of we can reduce the environment burden into our global sustainability. All right, so I do appreciate for your invitation to share with this session, and I thank you for your think of the climate change as we are working in the engineering and architecture. All right, so we hopefully we do this for our next generation. All right, we have to think, I mean, we have to make adaptation to the climate change that start from us for the next generation. All right, so thank you so much, and you can actually find for more reference from our research works, you can go to my Scopus research and have a lot of topics which is related to the sustainable construction material. All right, so that is it for my session. Right, thank you so much.
Thank you very much from Mr. Lim. That's very great topic. I mean, like, yeah, towards the adaptations of everything about how the behavior of from us, the behavior from the world of construction, and also our yeah our behavior in how we use the energy and how we use the energy for the construction and the after the construction or yeah, with everything. Yeah, we actually use so much energy that I think it's hard to count. But yeah, the approach from every point that you mentioned about I think we can use it in any other project, in maybe in the university project or research project or in the practitioner project. I think it's okay. Yeah, and hopefully we can collaborate. Yeah.
Sure,
Okay.
yeah, I remember one time like from the university from Indonesia, they're trying to reach me for using the fly ash, I think, from the mining area and to produce
Oh,
fuel as
yeah.
well. Mm.
Right. Okay. And then how it goes.
Yeah, I proposed some technique, but now it's like they say that their university is now in the time or in the period that changing the head of school, like the head of the
Oh,
institute,
okay.
that
Yeah.
is going to be postponed. Mm.
Yeah, because in here, yeah, Indonesia is a lot of minings, yeah, from
Right.
yeah, mining. So I think it's the fly ash from the bottom ash. There's so many here, so I think it should be useful, not
Right.
just the I think it could be like just a residual things, but it could be used to be the sustainable material as well. Yeah. Okay. So Mr. Lim, I think we should just move to the second session from Mr. Hani, and then after the second session, we'll be going to the Q&A session. Yeah, okay. I think all of the participants here, please be patient first if you want to ask to Mr. Lim directly. Yeah, okay. Okay, Mr. Hani, I think it's your time. Hello, Mr. Hani.
Oke, halo.
Selamat pagi.
Selamat pagi dari Thailand, Pak Adit.
Apa Mr. Hani? Selamat pagi.
Iya. Sawati aja, Sawati.
Sawati, oke,
Iya.
Sawati.
Oke, terus
Oke, ya,
pakai bahasa Inggris atau bahasa Indonesia aja ya kalau aku.
yeah, I think we can mix them up. Yeah, okay, it's okay. Yeah.
Oke.
So yeah, I think we can use both of language in any
Okay.
other tense. So Mr. Lim, I think I can understand as well.
Ya,
I think
oke.
it's good to use the two languages. Okay,
Oke,
Mr. Hani, it's your time. I think what things that you're gonna bring up to us today? What about what that you're
Okay.
gonna present about?
Okay, first of all, thank you for the invitation from Adit, yeah, and then for the University of Muhammadiyah Banjarmasin. I'm very grateful to be here to send and then share our knowledge from the Thailand. So today we will share about the green architecture, yeah, because of there's a lot of architect students and then practitioners of architects. So I will talk about the green architecture deeply here.
Okay. Yeah, Mr. Hani.
Okay.
Yeah. I think you
So
already sent the
yeah,
some maybe two documents
yeah, I
about
have the two documents
OTTC.
because a lot of number there. So I hope that you can open the files during the presentation.
Oh, okay.
Okay.
Yeah, thank you, Mr. Hani. I think you can take your time, please.
Okay, wait a moment. I will share the screen first. Okay. Good morning, everyone. So my name is Hani Chandra. I'm a PhD student in the School of Civil Engineering, Suranani University of Technology, Thailand. And then Dr. Meng Lim Hoi, or I usually call him Achan Lim. Achan is a lecturer in Thai language. He is my lecturer, so still young, but has a lot of power to do research. Yeah, I also appreciate of him also. So this is the topic that I will deliver to all of you is the green architecture, not only just a gimmick. Yeah, sometimes like every architecture designs, they usually put always green or like saving energy. Yeah, this is green, this is green. But actually, we even don't know about what is the green architecture actually. So here we will talk about the green architecture so we can claim our design is green or not green architecture. Before that, we just this is the briefly introduction of my profile. I graduated from the same university with Pak Adit in University of 17 Agustus 45 Surabaya in Indonesia. And then I continue, I work actually, after finish, I work as the assistant site engineering in one of the construction company in Surabaya, and then continue Master of Architecture in Thailand in Konkan University. And after that COVID, I can come back to Indonesia, and then I should continue my doctoral in Suranani University of Technology and meet Achan Lim. Okay, so I have a fun fact. Actually, it's not fun fact. It's not fun, but facts. Yeah, in architecture career, sometimes this is in Indonesian memes. Ngerjain desain cepat. That doing the design is very fast. Why it's so expensive? The client asks like that. So sometimes like a lot of non make sense question from client that actually they don't know about the architects. For example, the second one is the fee, about the fee. Right? Harganya 150.000 per meter persegi. Oh, 30 juta ya? Oh, saya kira cuma 3 juta. It's happened. Hey. It happened, I think, all of the our field, especially for the young architects. For me also, I have an experience like actually it's not that, it's not, I cannot accept it because they are also architects also. For example, they have a project and then asked me to help, and then I put some of the price and then some of the scope of works, and then they said like, why it's very expensive? Oh yeah, I know, like because you are a PhD students. I think it's not fair. I mean, like it's not that true. Even it's the architect also see the other architects is with a low value. So I hope that all of you, being an architect, that appreciate and then like menghormati ya, like other architects also. So sometimes we forget that the role of architects. Usually, when we talk a client with a client, we just wants to be grab a money and then follow their wants. And then if only we thinking about the make the design, we just actually only have the direct only. For example, like this client aesthetic, but we hammer back being the architecture, we have the we have the important role that we mix with the other difference. For example, like what is the difference between the architects and then the drafters? For example, like they working in the same field but different roles. Sometimes the drafters can get or can grab the projects by giving the less cost rather than the architects, right? So, but we have to stand with the architect roles. What is the architect's roles? Architects play a role in determining the sweet spots. Sweet spots, it's like the right spots between the budget balance of the client, aesthetics, and the efficiency. But usually we forget about the efficiency. We just only put the client budget and then doing the aesthetically. But we have to remember again about the efficiency. What is the aspect of the efficiency? It has a budget efficiency. It's talking about the budget. And then room efficiency is talking about the aesthetic or planning or facade, anything. And then energy efficiency is talk about the efficiency. Kalau semakin kita tarik ya ke aesthetic and then efficiency, the client will be paid much. It depends on the client budgets. If they have only middle budget, so we have to take all of those efficiency and aesthetic in the right place where they can get the higher aesthetic and then much efficiency also. That's the role of architects. So I will talk about this point. Today I will not talk about the aesthetics, but because of the topic is the sustainability and then the climate, so I will talk about the efficiency. So efficiency, energy efficiency, usually the commercial name or in the architecture field, we say or we name it as a green architecture. What is the green architecture? It's the integrating building with the environment in mind by using sustainability source of energy, and then designing efficiency to reduce the energy, and then update the existing building with the new technology. Yeah, that's the integrated buildings planning. But there are many designers claim that their designs are green as a gimmick to sell their design, right? Sometimes we don't know about what is the green, but just put LED lighting. Yeah, we say it green. Yeah, this is my design is already green. Yeah, and then clients doesn't know greens also, and then oh yeah, okay, I will pay it. And after they build it, the design, and then it's not far away from expectation. That's usually we have to aware about it. So talking about the trend architecture in 2023 has 5 big trends. The first trend is a green architecture. So that's why a lot of like carbon emission strategy, and then we know that the government of Indonesia also plan sell carbon today. Yeah. After I looking for the green architecture in a Google, I type a green architecture. A lot of times, a lot of picture appears, and sometimes I found that the not appropriate design that actually they claim as a green architecture, but I don't know actually. I just looking at the first site only, but I think sometimes we can analyze that it's really green or not. For example, how can we know that green architecture or a building is a green? It's just because of the first picture, because just put a wood material, or the second one is just put a high ceiling is already green architecture, or planting trees a lot, or just put solar panel, or just have a green rooftop. Nah, actually, the answer of all this question is it might be a green architecture. Ya, itu mungkin semua adalah green architecture. Tapi kita harus make it sure. We have to know what is the basic of green architecture. How can we know the idea of the green architecture? Actually, we have to refer to the standard. The international standard has a lot of standard for the green architecture. For example, like LEED, LEEDs from United States. But actually in Indonesia also has the standard is in the Green Building Council of Indonesia. It's actually adopted from the international standard. It's like 80% is the same standard of the international standards. This is the point of the standard. For example, like appropriate site development, energy efficiency, water conservation, and any others. We will talk about the number 2. But if you interest to download the green ship or like the requirement for the green buildings, you can scan this one and then you will get the form from the Green Building Council to assess the green building. So if we make apple to apple, actually the international standard and Indonesian standard is very different in terms of the details of the parameters. Because of in international standard, they refers to the weather and the climate of the America. So they have to put the heating and cooling inside, and then water heating also. But in Indonesia, as a tropical climate, so they refers to use the passive designs to like this one is ventilation and the natural lighting, which is not mentioned in the international standard because of the different situation of the climate, weather, or anything factors. So yeah, that's the introduction about the standards. We will talk about this one, EECP2, because it has some of the parameters that talk about the OTTV. What is the OTTV? We will talk it fastly because I'm not sure that I have time to describe all of these things or not, but I will try. So the one to know that the designs is a green or not is by using the assessment of the Indonesian standard. And then we have to know all of the points. What kind of the parameters to assess the parameters. For example, one of the parameters is the OTTV. I'm not sure that do you have you familiar with the OTTV before? Yeah, OTTV is overall thermal transfer value, or it can be easy if we call it like a calculation of the thermal into a facade of the buildings. This is the formula of the OTTV. It's a lot of formula, but don't think that it's hard. But actually it's very easy because we have to put only and then just calculate it. We not to calculate all of the things, but we have to put every number only. Yeah. So we will try to talk about the every unit of the formula, started from the absorptancy dinding or absorptance. It is affected by the surface and the color of the material. For example, the black glass, the darkest the material, the absorptivity is higher. Right. This is the logical thinking of the materials. For example, black glass or black concrete is high absorptivity. Is it can be absorb the thermal easily if the color is dark. So this is the red one. I will use for the example later for the calculation example. So I just mark it to make it easy. And then after that, we talking about the U value of the wall. As we know that the material of the wall, we can make from any other things for this, whether it's like the not sustainable material or with the sustainable material, it has a value. For example, this one is the bricks, bata merah ya. Bricks has the thermal conductivity 0.77. But we looking for the like concrete blocks atau yang bata ringan putih itu ya, itu 0,20. Sorry, bata ringan like bricks has the density, has thermal conductivity is about 0.3 here. This is like concrete is another like concrete, the other materials. Next is the equation here. It have a different value. It's because of the orientation. For example, like the north has the different temperature is about 3 Celsius. And then the east has the 6 differentiation. And then any other else, we can reverse to these tables. And then WWR is a window to ratio wall. This means like the how large of the window to the wall ratios. Moving to the glass, the U value of the glass has their value also. For example, like the single glazing, like the normal glass, has 5.2 energy loss. As we can imagine, right? From the beton ringan, from the like bricks, is only 0.3. But if we put the glazing, even like a small glazing, it can be increase the temperature inside because of the energy loss is 5.2 watt per meter Kelvin. And then has the other one, the different temperature is the different outside and inside temperature. The standard of Indonesia, SNE, set at 5K differentiation is the like an average between the whole day of the condition outside and then inside. And then after that, we have the solar factors. Is the intensity of the solar through the window. In every orientation, they have the different value here. And then we have this coefficient of the glass. This is the shading coefficient of the glass. If the glass is clear, is higher. But if we put some of the low E screen to the glass, it will be reduce the shading coefficient. And then this is the cover coefficient. If they have the overhang to protect the window, it can be reduced the solar factor, which will inside to the building. So actually is a lot of data, but we don't need to worry. We can try together. Yeah, by using the Excel. I have an Excel you can try to open. If you have time to open, you can open and then put some of the value there. This is the example. I have the 3 by 3 and then by 3 meters of the rooms with 4 square meters of the window here on the west, at the west and at the south. So the question is how many the OTTV if I use the material bata ringan at the first, and then dense concrete or beton, and then the third one is the lightweight concrete beton ringan. So we will open the Excel. Yeah, I have the calculated one already here, but if you want to try, we can try it together in the mock-up here, because it might be useful for you to assess the building, like the basic assessment for your buildings. Even actually for the OTTV or RTTV, actually it's many plug-in to calculate. For example, like Energy Plus software, or sometimes we can calculate this one also in Revit, because in Revit has a calculation for the energy building, or we have a plugin also. It's already released the plugin OTTP for the SketchUp. We can use it. Yeah. So we can claim the energy, the green architecture of our building. For example, we have to input the data first of the window wall ratio from the west and the south. It because of the same value, so I just put one of the data here. 2 by 2 windows is equal with the 4 square meters, right? So we put this one. This is the Excel calculation, right? We put the 4 square meters divided by area of the wall. How many area of the wall? How many square meters? 3 by 3 is 9, right? Okay, 9. This is the wall window ratio, 0.4. Okay, so we have to, after that, we have to choose the U value of the air concrete or bata ringan. We have to open the bata ringan first. Where is the bata ringan? Bata ringan is 0.303. Put here, this one. We just calculate this one first. We will skip this first. We have to know how to calculate every single material first, and then area every side, because of this is a simple model, so every side has the same of area. 3 by 3 is 9. Just type 9 here. So after that, we have to put the absorption factors. This one. We have to assume that what kind of the finished material that you want to put to the buildings. For example, we just color it for all of the side. Yeah. So put the beton concrete, sorry, bata ringan. It's a bit confused Indonesian and English. Put the U value of the added concrete here, because we will use all of the same material in every facade, so just put it the same number. I already put this one because it's takes time to put this one, but you just refer to the differentiation of the temperature here. For example, is the north. You can open the table of the temperature difference. This is the north. You have to estimate the weight of the material in a square meter. So for the bata ringan, we assume that it's about 23 kilograms to 200 kilogram per meter squares. So we put this number to our formula. For the east and then south and then west also, just put it to the formula here. Okay, and then after that we put this formula 1 minus wall window ratio, this one. Oh sorry, this is 0 because on the north facade they don't have the wall window, but the window is existed in the west and then south only. So we just put this one minus for the wall that has no window, we just put number 1 because 1 minus 0 is still 1, so just put it with 1. So we already have the OTTV for the north facade and then east facade here, because we don't need to calculate the glass conduction and then glass radiation. Until here, is there any question? I hope that you can follow our explanation. Is there any question? No, yeah. Okay, I will continue first. For the south and then west facade, we have to put the value of the glass. We will put the ordinary glass, like the cheapest one. So that's why if you use the cheapest one for your construction, your building will need more air conditioner. So during the planning of the design, we have to talk with the client and then educate the clients also what the effect of every material. So we estimate that we use the single glazing, like ordinary glass, 4.2. Put this one 4.2, and then also this one 4.2. This is the SNE standard 5 temperature different, and then wall ratio, put this one. We get the number of the glass conduction. We move to the glass radiation. For the solar radiation, we have to back again to this one. Yeah, this is to the south and then west. Put this number to our Excel. For the south, how much? 191, and then for the west, 175, and then this one, the cover coefficient. If we don't have the coverage, because our example they don't have a shading, overhang shading, so we just estimate to 0 shading, which is 1 coefficient. Put 1. But in case if you have shading, you just calculate first the OPF here, the overhang divided by the height of the window. So you will get the number of the OPF, and then looking for the coefficient of the shading here. And then after that, the coefficient of the glass. For the clear glass, 0.8. Just put the 0.8 here, 0.8 here. And then This is the window ratio. Yeah. So we have the calculation of the total of the OTTV for example building. We use the A-rate concrete or bata ringan. The total of the OTTV is 39.09, which is the standard in SNE is no more than 45 watt per square meters. So it passed the standard. But for the green architecture or green building council, they have the standard of the ranking. The basic one is the 45. It's like the silver one. And then I'm not that remember, but let me guess. That's usually that's a 30. Below 30, they will get the gold platinum certification. And then it's if below 25, it's a platinum. So that's very, very low OTTV. What is the effect of OTTV? Its effects to the how many air conditioner that you have to put to make the rooms back to be a normal temperature or like the human comfort temperature. So for example, if you have 39 watt per meter squares, we have to back to the area of our example. We have 9 square meters of the floor. So we have to multiply the total of the OTTV multiplied with the 9. Sorry. With 9 square meters. So you have put the half of setengah PK ya, half PK or something, or if it's equal with the around 7,000 BTU for air conditioner. But if you have lower of this one, you can put one of half PK also with the lower more efficient electricity to use the air conditioner. That's the effect of the OTTV. That's why when we want to design and then choose the material, we have to consider about the material. What kind of material that we want to use. Okay, so I will not calculate all of these example because we have the limited time, but we have the answer here for the differentiation of the 3 materials. This is the result of the calculation for the A-rate concrete or beton ringan, bata ringan, sorry, 38.04. If we use the dense concrete atau konkrit yang ada batunya itu ya, yang kayak konkrit precast atau segala macamnya itu, it will takes the 44.08 watt per square meters. And then if we use the lightweight concrete, the OTTV is the lowest one, 37.77 watt per square meters. So yeah, if from the calculation, we know that if the material they use the lightweight concrete or air-rate concrete, it make the more efficient than the concrete or actually for the bricks bata merah yeah, because of the U value is the different and then the absorption is different also. Okay, so I will explain some of our research that I worked through in SciCon. Our university has the research with material development. It's called the lightweight cellular concrete that at that moment got the lowest OTTV value. That's why our works, we interest to develop the lightweight cellular concrete. And then what is the live cellular concrete? It's actually a concrete, but we replace the rocks by using the foam. Put the foam inside to make it lighter than the concrete as usual. And then also this is the benefit of the LCC. It's a lighter because normal concrete, they have the density 2,400 kilogram per square meters. But for the live cellular concrete, it started from 800 kilogram per square meters to 1,800 kilogram per square meters. It's half lighter than normal concrete. Because of light, it's saving costs for the structural design, and then also water resistance, low heat transfers, and then sound absorption also because they have a pores inside. As we can see in our short video here, this is our testing of the lighter concrete. This is the pataringan. This is the light bridge here. It's already sink into a water, but our live cellular concrete still on the surface of the water here, the circle one. And then this is the normal concrete. Yeah, as we can see that the live cellular concrete still can on the surface of the water because of lighter than the other materials. So why it's lighter? Because we put a foam here. It's the process of the mixing of the concrete. As we can see, the mortars, semen ya, dicampur dengan foam. That's why after it's hardened, they have some of the pores here. Sorry for has some of the bubbles for the one who cannot see a bubble like this. I'm sorry, but that's the scientific laboratory. If we make, if we see by the microscopy, or we usually call it SEM, it's shown that has a lot of pores here, and then that's why it's make lighter and then have the other benefit of the properties. So for our project, especially my project in my PhD, I interest to use this one to the green roof application. As we know that the green roof has the effects to help the buildings to improve their rating of the green buildings. So I interest to apply this kind of the concrete to be the green roof application here. This is the model test of the green roofs, where the first layer is the LCC, live cellular concrete, and then just put the soil and then put the grass, and then the performance of the grass is very high also, the performance. Why I have to replace the green roof to be using the LCC? Because in the market like the Euro or America, it's already popular green roof already, but actually the cost of installation is very high. In Indonesia, I can say like for the 1 meters, it's cost about 3 million rupiah, 3 million rupiah per square meters for the green roof. It because of they have many layers, they have to buy every system to put the grass over the rooftop. But we interest to our new innovation by replace all of the layers to be using the LCC as the base of the green roof, and then put only directly the soil and then grass only. Why it can be like that? Because green roof like with solar concrete actually has the properties, like the good properties to replace all of the function of this this layer. For example, I put some of the example in the surface of the live solar concrete. They have some of the pores that can keep water to make the soil still in the good humidity to make the grass still grow. So that's why LCC has the potentiality to replace and then apply to the LCT. Because of the system, I can saving the cost 4 times lower than the old system. For example, like the green roof old system, they cost around 3 million rupiahs, but for our system, it's just only 500,000 to 1 million rupiahs only. But we can get the same benefit with the green roofs. This is the test of the green roof. Where is this? This is the drainage system where I must to make sure that the LCC can hold the water, which is with no leakage, and then still drainage the water properly. And then this is also the model where I put some of the lighting for the growing grass, and then it's still growing until right now. So this is our project also is collaborate with the biggest company for the cement construction. Actually, SCG has also in Indonesia. I think in Jakarta they have the SCG company also. We Cycon and SCG now is construct the 2 of the variable of green roof, whereas the LCC is our system, and then the EPS foam by using the foam is actually a system from the Germany. So we will in the next week we will keep the sample of the performance of the LCC and then EPS. So it can be like a Thailand versus Germany, and who will win, and then SCG will make it to be their new product to sell to the market. Yeah. Something like that, or for all of the what can I share. So if you want have a question, feel free to ask. And then if you have or interest with this topic or wants to get some of the scholarship to study for master or PhD, you can also contact me or Ajahn Lim also, because we offer a scholarship for the students who interest with the sustainability. Okay, thank you.
Thank you very much. Terima kasih banyak, Mas Hani. Khobun Kap.
Ya, semoga nggak ini ya.
Ya,
karena
Khobun Kap.
perhitungan ya.
Ya, Khobun Kap, Mas Hani and Khobun Kap for Mr. Lim. Thank you very much ya. Terima kasih banyak sudah menyampaikan banyak hal ya di sini. Thank you very much for all of the things, and you both already shared to us about the how we manage the sustainability towards the constructions. Yeah, the in the construction processes or in any material things such as like the hempcrete or any residual things that could be useful in order to adapt in the climate change or to solving the climate change issues. And also from Mr. Hani, the how to calculate the building performance through the using the sustainable material with count the OTTV amount. Betul Mas Hani ya?
Ya,
OTTV, overall
OTTV.
thermal transfer value, betul ya? Ya.
Yes.
Ya itu sekarang kan lagi on banget nih, lagi on banget ya di manapun ya di seluruh dunia ya karena banyak berdampak kepada building performance. Jadi dampaknya tidak hanya untuk iklim ya, untuk iklim mikro makro tapi juga terhadap keberlangsungan atau keberlanjutan kehidupan ya dan juga kenyamanan thermal, betul ya Mas Ani?
Benar, karena bakal ada efeknya kalau walaupun kita desain, terus kita desain dengan harga murah, material murah, padahal kita nggak edukasi klien, pokoknya murah, oke, klien
Iya.
suka karena harga murah, padahal waktu bangunan itu sudah terbangun, klien bakal komplain karena
Oh ya.
sama sekali nggak nyaman. Nah, itu yang harus arsitek hindari mulai sekarang, karena menurutku itu yang membedakan arsitek dengan disiplin ilmu yang lain.
Ya.
Walaupun banyak disiplin ilmu yang mengaku bisa, oh, saya bisa mendesain rumah, desain ke saya aja murah, saya bisa gitu. Tapi kita
Desain
harus
pakai dengkul ya Mas Ani ya.
ya desain pakai dengkul ya. Tapi kita harus tetap berdiri sama role kita sebagai arsitek. Kalau kita harus memikirkan segala aspek supaya klien itu nyaman, harga nggak boros, tapi dapat keefisienan itu, Mas Adit.
Ya, terima kasih. And Mr. Lim, you still here? Okay. Thank you. Thank you. Still on on the record, on the Zoom. Thank you very much. And we talk about the sustainability, how the strategies. Yeah, actually, maybe in the next seminar or in the next time, you can maybe delivering detail about the how you work, about your work and about anything. So I think in this is just not a webinar. This is just not a usual seminar, but also we can. I think it's like the. I think we can call it an international forum for us to meet each other and we can talk about the climate change and how we can solve the problem about these issues and also how we connect each other and maybe we can make work or project together to make the better world, right? Through the strategy that you already mentioned about. Thank you very much.
Thank you. Sure, yes. I think we have if sometime I can share for deep detail about research work or about the sustainable material in our research team, rather than just like for this time, maybe it's just like the overall.
Yes.
In the future, I
think if we maybe have some time and some another things that make like bring you, both of you to Indonesia or vice versa. I mean, like we go there and you go here and make an international workshop as well. I think so. It will be great. Maybe next time or who knows, right?
Right.
Okay, I think due to the time, the rest of the time, I think we can move to the Q&A session. Okay, from I think from the chat box, we have any questions from the participants. Maybe you can raise your hands if you want to ask directly to the speakers, or you can type down your questions and I will read it for you.
Tadi tanyanya juga bisa pakai bahasa Indonesia ya kali, atau bahasa Inggris pun juga boleh.
Betul Mas Hani, setuju saya. Ya, kalau ada yang mau pakai bahasa Indonesia boleh. You can use your maybe in English, it's okay, or you can use if any of the participant already know about the Thai language. you you can ask in Thai. It's okay.
Misi saya bertanya,
Ya, silakan Bapak, boleh.
itu Hani untuk membuat arsitekturnya, arsitektur pool yang saya dengarkan kepada si Hani,
Iya,
saya ini membutuhkan pool untuk membuat rumah, kayak seperti gamenya House Flipper, Playway, dan Building Simulator. Dan 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 saya dengarkan the answer for Menglim Hoi of the railway road in train road. This is a road transportation. Okay, this an airport is road plane and approaching approaching road. Okay, thank you. Kasih.
Oke, terima kasih Bapak atau Mas Rumambi Samuel. Mungkin Mas Hani bisa menanggapi, or I think
Okay.
from Mr. Lim, you can answer it. Okay, it's up to you.
Okay, so I'm first. Okay. So thank you, Mas Rumambi Samuel. For the simulator, untuk simulator ya, sebenarnya saat ini itu sepertinya banyak ya beberapa aplikasi yang bermunculan gimana kita itu bisa membuat rumah sendiri dengan AI tanpa bantuan arsitek, lalu dengan room planning. Saya pernah lihat di iPad atau mana gitu ya, itu ada kayak panduan gimana sih cara buat ini segala ini. Itu bagus menurutku. Tetapi untuk kembali lagi untuk membuat rumah itu efisien, tidak oleh karena itu harus ada bantuan arsitek. Arsitek itu ada untuk sebagai konsultan, sebagai pengarah supaya mana sih baiknya itu yang mana, efisiensinya yang mana, lalu cara membangun dengan harga minimal itu seperti apa, daripada tanpa arsitek membangun atau membuat melalui aplikasi dibuat sendiri lalu dibangun tanpa ada konsultasi, sangat beresiko terhadap malah lebih kehilangan biaya lebih banyak daripada menyewa arsitek. Dari mana kehilangannya? Pertama, kesalahan saat membangun. Misalnya harusnya kolomnya sebesar ini, sebesar misalnya 30-30, ternyata pertama bangunnya cuma 20-20. Terus dapatlah output dari tukang. Ini kalau 2 lantai harusnya 30-30, Pak. Gitu. Salah ya berarti 20-20. Bisa nggak ditambah? Bisa. Jadi 30-30 ditaruh fondasi baru, dikasih penyangga baru, tapi cost bakal lebih nambah. Belum lagi kalau itu harga di markup ya, dinaikkan sama kontraktor sama pemborong, karena pengetahuan kita juga masih kurang terhadap harga material, karena kan kita nggak mungkin sebagai owner kita mengetahui banyak harga segala macam harga material. Nah, itulah fungsi arsitek, harus ada pendamping arsitek supaya saat ada hal yang out of control, arsitek bisa take over supaya untuk mencegah ketidakefisiensian itu, Mas Rumandi. Ya, I think like that the answer, Pak Adit.
Oke, terima kasih banyak Mas Hani. Gitu Mas Romambi, mungkin itu tadi ya. Ya simulator itu mungkin banyak ya. Ya, tergantung kita mau milih yang mana dan tujuannya kemana, tapi tentu peran dari seorang arsitek atau perencana itu pasti sangat krusial karena mendukung terhadap bagaimana proses pembangunannya sampai keberlanjutan bangunannya gitu ya. Oke.
Restoring
Ya.
filter.
Ya, restoring. I like that words. Terima kasih. Mungkin ada dari peserta yang lain mau bertanya. Mungkin dipersilahkan. Oke, tadi ada yang angkat tangan ya. Boleh, silakan. Mohon maaf tadi siapa ya yang itu tadi? Yang raise hand tadi, mungkin boleh sekali lagi. Karena ini mungkin hampir mendekati jam itu ya, jam selesai. Mungkin kita bisa membatasi pertanyaan, mungkin cukup untuk 2 pertanyaan lagi mungkin begitu ya. Boleh, apabila ada yang ingin bertanya ini saya tunggu mungkin sampai jam 11 ya. Mungkin sambil menunggu saya bisa ngobrol-ngobrol juga dengan Mas Hani. I think we can have a this little discussion about about the ini ada ini. I asking for 2 guest lecturers. Yes, please, you can ask directly from Aura Medina.
Ada atasnya Pak Evan itu.
Oh ya, Pak Evan juga. Oke, Pak Evan, there are any specific criteria for material categorized as the sustainable material? Yeah. Yeah. There are any specific? Yeah, please, Mr. Hani, Mr. Lim.
Okay, so maybe I can. All right. All right, thank you for the question. Evan, is there any specific criteria for material and categorized as a sustainable material? No? You raised the question. That is very good question. So I think, yeah, of course, it will be have a specific and a particular criteria. So it also apply for the specific application as well, right? For example, if you say that a specific criteria, it should be applied for a specific pavement, for example. I take an example of a pavement. For the concrete pavement, the specific criteria, it should be the strength, the compressive strength, and the flexural strength, all right? So concrete is subject to the compression, compression due to the vehicle load, for example, all right? So that specific, it should be have the capacity can carry out the load more than at least 32 MPa, for example.
Oh.
All right. And for the flexural strength, for the bend, because pavement is just like the slang, it should be have specific not less than 4.2, for example, MPa. That is the mechanical strength. That is specific. But when you say that the specific or cut strength for a sustainable material, it's mean that if we put making a concrete, that is not really specific, but it can be reduced. For example, a concrete made up of aggregate. Aggregate is like crushed rock or sand from the river, a limestone from the mountain area. But so if you could use the recycled material from the building, from the old building, when you dismiss it and put in it, so we can now reduce the material. And for the cement is one of the significant or key driver to the climate change. So if we can reduce it, and now in Thailand, SCG or a lot of companies, they're trying to reduce the amount of cement. So you can substitute fly ash into that. So this is the specific criteria, which can reduce the environmental burden. I hope that might be can be the answer for your question.
That's the answer from Mr. Lim, Mas Evan Supar. I think yeah, it's approved by him. Yeah. If I may to make it short, I think that the sustainable material is like the strength is as strong as the conventional material, but in India, in the other hand, also like it lighter and gives so many benefits to the constructions, and because it's like use the residual material, and the strength is stronger than the use conventional material, and also it's lighter. But actually, still, I think the sustainable material, why the people still here still in uncommon, because I think it's still hard to find or hard to applicate, or they didn't still don't know how to use it properly, I think. Yeah, what do you think?
Right. That I agree. Maybe I add up a little bit because I forget it. We are working in the architect a relationship between the engineering and architect. So yeah, I try to mention a little bit. For example, I'm also working with the material for the construction, especially for architect. If you could reduce the amount of the raw material as the natural material, for example, the wall, the roof, or whatever, which is you can try to include or add the renewable material in your architectural. It might be also can have these considered as the sustainable material. Right. But the thing is, for example, the wall or the bricks, it have the specification. That brick or that blocks or that structure, it can meet the engineering criteria or not. Okay, so it can be subject to the strength. So I think that is mostly it can be considered.
That's mean the engineering criteria. It should meet that criteria, the engineering criteria.
Because we cannot apply, for example, 100% of that material, but maybe can reduce. So the way that I always present this to the audience, or that we're trying to address or like highlight the benefit of the sustainable material, is we can reduce the raw material, of course, and we can reduce the greenhouse effects. We can calculate it based on the construction process.
I understood. Yeah, I agree with that. Okay. I think this will be the last question from Aura Medina. You want to ask to the two guest lecturers directly, or you want me to read it for you for the questions?
Sure.
Okay. Hello, Aura.
Hello. Okay.
Do you still remember Ajan Lim Aura?
Okay. Thank you to Mr. Lim and Mr. Hani for very interesting the presentation. So my questions are, instead of maintaining the environment, we have to using the sustainable materials. But what if that the materials we use can create dependence on nature, so we eventually got damaged environment? And for the green roof system, it's possible we can use ornamental plant types, or there are special specification to apply for green roof system. Okay, thank you.
This might be go to Hanina.
Okay. So thank you for the question, Aura. Aura is last year was visit as the student exchange in our university for 3 months, right, Aura? 3 bulan ya,
Yes.
3 bulan. And then she also watched a lot of the material development here, and then how to develop the lightweight solar concrete and then green roofs as well also. Yeah, but they have a limited time, so the project is not finished yet, but Aura and then their friends already go back to Indonesia. But so yeah, I hope that there is another generation from UMB to come as the student internship again this year. So answering the question from Aura, actually we have to Yeah, actually talking about sustainable material is we have to kita harus ini ya kayak mengakui kalau untuk menggunakan sustainable material terutama ke klien is still hard, masih susah karena mereka punya standar, pasar punya standar, perusahaan juga punya standar, dan mindset klien atau mindset untuk atap harus pakai genteng, gimana nggak bisa pakai green roof, nggak bisa, nanti bocor lah segala macam atau apa. Itu kendala yang masih ada di dalam industri pembangunan ya di Indonesia. Jadi sebagai arsitek kita harus mencoba approve the sustainable material by ourselves. Apakah kita beneran tahu nggak sih semuanya harus di-approve kayak tadi aku cerita tentang green architecture. Gimana sih tahu dari green architecture itu apanya? Gimana cara tahunya itu green architecture? Kita harus approve by standard. Sama kayak material, gimana material itu bisa have the enough compressive strength, have enough property, and then quality same as the market. Jadi kualitasnya harus sama. Oleh karena itu kita harus cari tahu nilai-nilai standar dari standar yang ditentukan. Misalnya strength-nya harus berapa. Nah, cari info strength-nya yang sustainable ini harus berapa. Karena sistemnya sustainable material itu kita seperti yang dikatakan Acam Lim tadi ya, Dr. Lim tadi, kita nggak bisa replace semua. Kita punya bata, terus kita mau ganti 100% bata jadi material yang sustainable 100% nggak bisa. Kita hanya bisa replace. Replace itu 20%, tapi itu yang harus kita teliti lagi kalau sustainable material itu sesuai nggak sama kualitas market. Paling nggak sama kualitasnya, sama kuatnya, sama tahan panasnya, sama nggak kedap suara mungkin juga bisa jadi parameter. Lalu untuk green roof sendiri, tadi pertanyaannya green roof apa lagi tadi kalau green roof?
Untuk kayak pengaplikasian green roof itu Mas, apa ada kayak spesifikasi untuk tanaman khusus buat green roof gitu Mas?
Ada.
Apakah boleh kayak cuman kayak tanaman hias atau cuman rerumputan atau pohon-pohon gitu Mas?
Nah, di dalam untuk pengaplikasian green roof itu ada standarnya. Standarnya kebetulan saat ini yang paling banyak standar dari Jerman. Di Indonesia masih belum ada standar, ataupun di Thailand juga belum ada standar green roof. Jadi untuk acuan gimana cara membangunnya, terus kualitasnya green roof-nya seperti apa, itu kita refer ke standar. Terus ada jenis-jenisnya. Kalau misalnya kebetulan jenis yang green roof yang saya kembangkan ini itu green roof extension. Jadi untuk tanaman jenis kecil, akar kecil. Jadi seperti tanaman hias yang semak-semak kecil, bunga-bunga itu masih bisa, sama rumput. Tapi ada juga yang semi extensive. Jadi itu kayak sedang, untuk tanaman berukuran sedang, misalnya pohon dengan ukuran kecil, terus hiasan yang biasanya di rooftop hotel-hotel, itu semuanya sistem-sistem semi extensive. Lalu ada juga yang sistem green roof intensif, itu yang bisa ditaruhin pohon besar di atasnya dan bisa kayak taman yang full landscape. Nah, jadi kita harus tahu juga jenisnya apa. Dan juga yang kebetulan yang sedang kami kembangkan itu juga itu kan mengubah dari green roof yang ada saat ini menjadi green roof yang memakai lightweight cellular concrete. Nah, itu nanti bakal juga dibandingkan apakah kualitinya itu sama baiknya dengan yang udah ada, atau bahkan kalau misalnya nggak lebih baik, paling nggak pas standar. Jadi lebih standar yang sudah ditentukan, baru itu bisa dipakai. Jadi cara pola pikirnya saat kita mau mengembangkan material sustainability, kita harus tahu standarnya, kita harus tahu apa yang mau kita ganti, kita coba ganti, kita tes lagi apakah sesuai standar atau lebih baik daripada material yang udah ada, kayak gitu.
Oke, gimana? Itu tadi Aura. Jawaban dari Mas Hani.
Sangat dimengerti, Pak.
Terima kasih. Okay, I think that this is maybe the last question from this session. I think it's the time for us to end this webinar, and me as the moderator and the representative of Universitas Muhammadiyah as well, I would like to thank you very much to Mr. Menglim Hoy and Mr. Hani Chandra. Thank you very much once again. Hopefully we can meet in another time to discuss this more about the sustainable material and constructions. Okay. Once again, Kopen Kap. Okay. Do you have any
Okay, so maybe again, I'm very thankful for your team who organized this webinar, international webinar, so we can have a collaboration between our two universities. And I'm very happy. I'm very thankful as well for let me sharing this session, and hopefully we can have a future collaboration. I mean, if your student or your academic staff would like to come to visit our university, you are very welcome. Or we can have a collaboration between the research work or even a practical works. It can be any other form. All right. So we are very happy to join us the team. All right. So thank you so much.
Okay, thank you so much, Mr. Lin, for the informations and also the chance to have a collaborations in any other sectors from both of universities. Yeah, it's a very cool. It's very good chance. Thank you very much. And also, Mr. Hani.
Okay, so I also thank you for all of the staff from UMB because inviting us to deliver a bit of our knowledge. So I also invite all of the UMB students or lecturers who wants to make a collaboration, for example, like make a new material, sustainable material by using something put like some replacement of the material in concrete or in pavement or in anything. Yeah, we are open to collaboration. Yeah, because we have a clever lecturer like Achan Lim.
Yeah, agree.
He just got award as the young scientist yesterday.
Thank you.
So yeah, that's why we are open to collaboration of the research. And then for our SciCon SUT also, we are looking for the master and then PhD student also for who interest in material development, sustainable development. It's not that architecturally, but actually it has a connected with the architecture.
Yeah, let's still connect.
It's important because we can nowadays we no need to learn as the parallel, like we have to learn a lot of other disciplines, not only architects or engineer. If you have a chance to learn business, you have to learn business also. If you have to change to teaching, just have learn about teaching also, because all of the knowledge, it can be support of our core knowledge. Our core knowledge is architecture, but we have to learn about the sub core of our core knowledge. I think that's the last word of this from me.
Yeah,
Thank
okay.
you.
Thank you very much for the closing statements for both of the speakers. And also, I would like all of the participants here to please fill the attendance form by clicking the link in the meeting chat. Yeah. And tech person, yeah, for that, yeah, I think it will be available in the next 3 days from now on. Okay, I think that's all from me, and I think we should take a picture virtually. Please, yeah, maybe from the operator here. Maybe you can take the picture of us, please. Pak Protokoler, bolehkah dibantu untuk foto bersama? Ya, boleh dibimbing Bapak? Mungkin biar bisa di take picture gitu ya. Ya, mungkin ya. Oke. Boleh diberi aba-aba, Pak? Pak Farid? Sudah siap kah?
Baik, akan saya coba dari
boleh,
sini.
Bu.
Iya, baik. Untuk screen 1 ya. 1, 2, 3, ready. Please slide.
Apa semuanya kayak itu?
Screen 2. 1, 2, 3, ready. Okay, continue the last screen. 1, 2, 3, go. Yes, complete.
Okay, thank you very much.
Thank you.
Okay, I think I'm gonna give the rest to the MC. Thank you very much, everyone. Hopefully, we can meet in the next chance. Thank you. Bye.
Thank you very much, Mr. Menglin. Thank you very much, Mr. Hani. Thank you very much,
Thank you
my
very
team.
much.
Okay. We also would like to thank the audience for their participation and interest in sustainable material and construction toward climate change adaptation. We believe that the information present here will be beneficial to all who attend. We hope that the seminar will inspire you to take action towards your goals.
Terima kasih, Kopunka, and thank you again for joining us today. We appreciate your time and hope to see you again soon. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.